Okay, last time we just solved a system of equations by adding the two things together because we had things that were the same coefficient in front and opposite signs. This time we're going to have to do a little bit of multiplying to one of the equations before we can do our adding of both of them. So this is called solving systems by elimination. We're going to multiply one of the equations by -1 and add. Why we're going to multiply by -1? Well, what happens whenever we do that is signs are going to flip in one of the equations. So as you can see in this first example, I got -x plus y equals -4 and 3x plus y equals -8. So I have things that have the same coefficient. Those y's both have 1s on them, but they're the same sign. They're both pluses. So I got to make those opposite signs before I can do my adding. So they can be eliminated. So I'm going to do the top equation and multiply by -1. That means that's going to give me opposite signs for everything in front of those numbers whenever I do that. So whenever I multiply this by -1, I'm going to do -1 times a -1x as 1x or just x. -1 times y is going to give me a -1y or a -y. -1 times -4 is going to give me a +4. So as you can see, every sign flipped in this. This became a +x, this became a -x, and this became a +4. Or -y, I'm sorry, -y. So +x, -y, +4. The other equation I'm going to leave the same. So then I can do my adding. What I need is to eliminate one of the variables. So I can do that now. Now I have y's that are opposite signs and the same coefficient in front. So whenever I add, those are the things that are going to be eliminated. So whenever I add these two equations, there goes my y's. I got 1x plus 3x is a 4x. And 4 plus a -8 is a -4. Now this is exactly what we had last time, and it should look familiar. Whenever we solve for x, I can just divide by 4. And I get x equals a -1. Now I'm going to plug that in to any of the new equations or the old equations. So I can plug into one of the two original, or even this one that I made, this x minus y equals 4, this new one that I made. I'm going to do I'll do that x minus y equals 4 equation. So I'm going to put in -1 for x and say -1 minus y equals 4. So I'm going to say a +1 whenever I'm solving for y. This is going to be 2 steps. So I got -y equals 5, and then divide by -1, I get y equals a -5. So my solution's -1, -5 whenever I write that as an ordered pair. Okay, now I can check. I can say -1 plus 5 is 4. That works. -3 minus 5 is a -8. That works. That solution -1, -5 works. And again, it doesn't matter which equation I plug that x equals -1 into. I could have plugged into either one of these two and gotten that -5 also. Okay, so the next example right here, I got a 3x plus 3y equals -3, and 3x minus 2y equals 12. So again, I have two things that have the same number in front, but they're both positive. There's no sign in front of those, which means those are both positive. So I have to make one of those negative. And I'm going to do this time, because it doesn't matter which equation I do, I'm going to do the bottom one and multiply that one by a -1 to change my signs. So that top equation is going to stay 3x plus 3y equals -3. And the bottom one, now all the signs change in front. So this is going to be a -3x plus a 2y, and that'll equal a -12 whenever I multiply by -1. Okay, now I have opposite signs and two things with the same coefficient. So I can add those two things together and eliminate my x's. So there go my x's, because a 3x plus a -3x means those are gone. 3y plus 2y means I got a 5y. And -3 plus a -12 is going to make it more negative and give me a negative 15. Now divide by 5 to get our y by itself, and negative 15 divided by 5 means y equals a negative 3. I can plug this negative 3 into any of the equations. It doesn't matter which one. I'm going to do this very first one this time because, like I said, it doesn't matter. This one just has the nicest numbers, I think. So this time I'm going to say 3x plus 3, and I'm going to put in that negative 3 that I found for y equals negative 3. So 3x will stay. 3 times the negative 3 is a negative 9 or minus 9, and that equals negative 3. Now I can do my two-step equation, add 9 to both sides, so I got 3x and negative 3 plus 9 is a positive 6. Divided by 3, I get x equals 2. Okay, so now I got my solution to negative 3 right here. So I can write my solution as 2, negative 3. And then I can check. I can put into the original, I can say 3 times 2 is 6. Plus 3 times a negative 3 is a negative 9. 6 minus 9 is a negative 3. That works. 3 times 2 is 6. Negative 2 times a negative 3 is 6. 6 plus 6 is 12. That works. So my solution to this equation is 2, negative 3. So again, why I'm multiplying one of the equations by a negative is so then I can do my adding and do my elimination of one of the variables. Right now, if I just added these two things together, nothing would eliminate because they're the same sign in front. Those 6y and 6y, if I tried to add that, I would get 12y. I need to be able to eliminate one, so I want to change the signs in front of one. This time, I'm going to do that because look, I got 6y and 6y. I'm going to do that in the first equation. So I'm going to multiply that top one by a negative 1 to change the signs in front of that one. So whenever I do that, I get a positive 9x minus a 6y, and that equals a positive 24. And the bottom equation will stay the same. X plus 6y equals 36. So I got x plus 6y equals 36. Okay, now you can see my y's are going to eliminate right away whenever I add these two equations because one's a negative and one's a positive, and they're both the same coefficient. So I can say 9x plus 1x is a 10x, and 24 plus 36 is going to give me 60. Whenever I divide by 10 and get x alone, I get x equals 6. So there's my first value. My x coordinate is 6. Again, I'm going to plug in to any of those equations. Me personally, I'm going to do this bottom one because it has, I can just put in 6 right away. It has a 1 for a coefficient. Its numbers are the best to me. So I'm going to say to solve for y this time, 6 plus 6y equals 36. Now there's my two-step equation to get y alone. So I'm going to do a minus 6. So I got 6y equals 30. And then divide by 6. I get y equals 5. So my solution for this one's 6, 5. That's my intersection point. If I plug that in to the original equations, negative 9 times 6 is negative 54. Negative 54 plus 6 times 5 is 30. So negative 54 plus 30 is a negative 24. That works. 6 plus 30 is a 36. So that works. So I know my solution of 6, 5 is right. Okay, one more example here to show you what to do to eliminate. Multiply by negative 1 and then eliminate. And again, I got 3x plus 2y equals negative 12 and 3x minus 9y equals 44. If I did this and just tried to add right away, again, look, I have two things that are positive. So nothing's going to eliminate if I just try to add right away. I'm going to get 6x minus 7y equals negative 33. nothing's going to be gone. So I have to multiply one of my equations by -1 to get opposite signs to be able to eliminate those x's. So I'm going to do the bottom one by -1. So the top one's going to stay, and I'm going to leave it as 3x plus 2y equals -12. And the bottom one, all the signs are going to change now. So I'm going to have a -3x plus a 9y equals a positive 45. Now I got things that are opposite signs and can add those two equations to eliminate my x's. So whenever I do that, I got x is gone. 2 plus 9 is 11y. -12 plus 45 is going to give me a 33 positive. Now I can divide by 11, get my y alone. So I get y equals 3. I'm going to plug this 3 in to one of the equations over here and get my answer for x, get my value for x. I'm going to do the top one again because it's small numbers. So I'm going to say 3x plus 2 times 3 equals a -12. Well, 2 times 3 is 6, so I got 3x plus 6 equals a -12. Now I got my two-step equation, -6. I'm going to get 3x equals -18 because a -12 minus 6 gets me more negative. Lose 12, lose 6 more, lost 18 altogether. So 3x equals -18, divide by 3, I get x equals -6. Remember, if I find y first, I'm plugging into y into my equation to get x. Make sure we're plugging into the right thing. So this time my solution's a -6, 3. And I can check. I can say in my original equation, -18 plus 6 is a -12. 3 times a -6 is a -18. Minus 9 times 3 is 27. -18 minus 27 is a -45. So that checks out. So I know my solution, or the things that make both of this system of equations true, or where they cross, is at -6, 3. So whenever we have coefficients that are the same but not opposite signs, we have to multiply one of our equations by -1 first to get opposite signs, so then we can add to eliminate one of our variables. And once we do that, we get the value for the one that's not eliminated, plug that into one of the equations to get the one that we did eliminate, and find our solution to the problem.